Ever wondered how off-road vehicles crawl over boulders, glide through mud, and storm across sand dunes without shaking themselves to pieces? Today on Knowledge Hub, we're diving into the hardcore engineering that lets these machines conquer terrain where normal cars simply give up. Off-road vehicles aren't just road cars with chunky tires, they're purpose-built systems designed around clearance, torque, articulation, traction, and durability. And it all starts with ground clearance. Off-roaders sit high above the terrain thanks to long travel springs, taller ride heights, and sometimes even adjustable air suspensions. This protects the underbody from impacts and allows the vehicle to clear obstacles without scraping. That's why icons like the Land Rover Defender and Toyota Land Cruiser can tackle deep ruts and rocky trails. Their chassis sits high and their approach, breakover, and departure angles are optimized to avoid bottoming out. But the real magic happens in the four-wheel drivetrain. Unlike regular cars that power only two wheels, true off-roaders use a transfer case to split torque between the front and rear axles. Many feature locking differentials, which force both wheels on an axle to spin at the same speed. So if one wheel is in the air or stuck in mud, the other still gets full power. Take the Jeep Wrangler Rubicon, for example. It comes with front and rear locking diffs, plus a locking center diff, giving it incredible traction on uneven terrain. Then we get into low-range gearing. This is essentially torque multiplication. Engaging low range slows the wheels down, but increases torque dramatically, letting drivers climb steep rocks or tow heavy loads at crawling speeds without stressing the engine. Vehicles like the Land Rover Defender and Mercedes G-Wagon have brilliantly tuned low-range systems that make technical off-roading feel controlled and almost effortless. But none of this matters without suspension that can move. Off-road suspension focuses on articulation, the ability for each wheel to travel up and down independently to stay in contact with the ground. Live axles, coil springs, multi-link systems, and even advanced setups like Land Rover's electronic gear suspension or Toyota's KDSS hydraulic system allow wheels to maintain traction even when the vehicle tilts aggressively. More wheel contact equals more grit, and the tires. They're the frontline soldiers. Off-road tires use deep tread patterns, reinforced sidewalls, and soft rubber compounds that deform over obstacles and dig into loose surfaces. Off-roaders in sand, like dunes in the Middle East, often run lower tire pressures to widen the footprint and improve flotation. Modern off-roaders also rely heavily on electronics. Traction control, brake-based torque vectoring, hill descent control, and terrain management systems are constantly making microscopic adjustments. The Defender's terrain response system, for example, changes throttle response, diff behavior, suspension height, and traction control based on whether you're driving in mud, snow, sand, or rocks, giving everyday drivers pro-level control. Combine all of this: high ground clearance, torque splitting for wheel drive systems, low-range gearing, advanced articulation, specialized tires, and smart electronics, and you get machines that can go where the road ends and keep going. Off-roading isn't just brute force, it's a masterpiece of mechanical and electronic engineering, working together to keep you moving when the terrain wants you to stop. If you enjoy uncovering the engineering behind off-road machines, don't forget to subscribe to Knowledge Hub for more deep dives into the technology that moves our world. And as always, stay curious.